says zinc metal reacts with hydrochloric acid according to the following balancing chemical equation. So I'm going to write this down first. So solid zinc plus 2 hydrochloric acids will react to form. I have a zinc chloride, the aqueous solution plus H2 gas. It says when 0.122 grams of zinc solid is combined with enough HCl to make 50.3 milliliters of solution in a coffee cup calorimeter, all the zinc reacts, raising the temperature of the solution from 22.4 to 24 C. Find the delta H for this reaction. It says use 1.0 for the density of the solution and 4.18 at the specific heat capacity. So what I wanted first to do is I want to look here at, I want to find the enthalpy of the heat of reaction, the energy, the delta H of this reaction here. And know that delta H here is going to equal, or you can think of it as Q equals MC delta T, right? So I'm going to say here, Q here equals MC delta T. And we want the mass here of our, it says here, we want the mass of our solution. So we want the mass of this guy first. And then we have C here, which is the specific heat capacity, and we have the temperature guy here as well. So we just want to figure out the mass of zinc chloride here. And in order for us to do that, we got to do a mole to mole table here. So zinc, I'm starting here with 0.122. 122 grams here. So this here is the mass, and I want to get the mass of zinc chloride. So I have to convert this into moles, obviously. And moles is going to equal, what happened? Moles is going to equal mass over molar mass, right? So I have 0.122 grams divided by the molar mass of zinc. So I can go back to my periodic table here. Zinc here is Zn, so this here is 65.38. And this will give me a mole of, let's see. I believe that the solution here is good, but I'm going to just double check it with my calculator. 0.122 divided by 65.38 will give you a value of 1.86 times 10 to the negative 3, which is good. I'll round it to negative 3 here. Moles. And again, this here is Zn here, right? So I want my, this here is my moles. And then what I have here is again, this is 50.3 milliliters of solution, right? And I want to figure out the solution here into integral mass here, right? So I know that the density of the solution equals mass over volume, right? And the density, I assume this here is 1.0, is equal to the mass divided by the volume here, which is 50.3 milliliters. 50.3 milliliters, which means a mass here, I can say that this here is going to equal 50.3 grams, right? So this here is good. And then what I have here is, what they're doing here is that they're doing, I want the delta H of the reaction, right? So again, I can use Q equals MC delta T to figure out the energy that's being released here. So I can say, because I have my mass, I have my specific heat capacity and my temperature, right? So I can say here that Q equals MC delta T. M here is 50.3 grams times 4.18 as my specific heat capacity, and the delta T here is from 24.7 minus 22.4, right? It's T final minus T initial. So 24.7 minus 22.4. Put this all into my calculator to get me 4.18 times 24.7 minus 22.4. It's going to give me a value of 483. Let me see if I got that. That's good. This here is also correct. So their math is good right now. This here is in joules. And then finally what I want to do is I want to find the delta H of this reaction, right? So I want to divide this number by the amount of moles of zinc here. So this here, I can say now the delta H of this reaction is equal to basically heat that's being released. So this here is negative Q, because again, this heat is being released, right? So this is an exothermic reaction divided by the moles of zinc here, and we're given that, right? So I have this here is negative 483.58 divided by the moles of this, which was 1.87 times 10 to the negative 3. Moles, this is in joules, and you would get my answer here would be negative 483.58 divided by, this is 1.87 times 10 to the negative 3. I get a value of, this is negative, this here is a negative 258,598.93 joules, or you can convert this into my kilojoules and simply just move this. I can simply just divide this by 1,000 to convert this into kilojoules here, which would get me negative 259 actually kilojoules. I'm going to round here. And this here is my solution, or sorry, this is kilojoules per mole. Joules per mole, joules per mole, and this here is my solution for this answer, and as you can see, this solution here is correct. Solution is correct. Good analysis here.